Osama. So, so I hope so far things are making sense. At least that's what I gather from some of the remarks from the chat. Sanad, Ahmed, Jihad, and Nania, and Mask. Okay, so now we have another small application, and I'm showing you some applications today so that you can actually have some idea about the various types of problems that that AI can help you in solving. Okay, so here is a small application again, which I'll be showing you. This is again a robot agent, and the purpose of this robot agent is this is called Rhino, and the purpose of this robot agent is that it actually is a guide, a museum guide. Okay, it takes people in a museum to various parts of the museum, and then gives an explanation about the various things that are placed uh, in the museum. I'll just play the video, and then we'll try to see that what type of complexities this type of an agent is actually facing. Okay. Okay, so yeah, so this is called a Rhino agent. Video is a bit old, maybe it has some resolution issues. So this is a guide that is taking these visitors to various places in the museum. You can see a small screen on top of this also, which explains about the exhibits present in the museum. Okay. Right. So I think this much is enough. So you have seen another type of agent here. which is um, uh, navigating in a museum, moving in a museum, and taking people from one place of the museum to another place of the museum. And then, of course, you have seen some complexities in this. So what are some of the complexities that your agent would try to say resolve in this type of a scenario? If you are to design a Rhino type agent, what would be the things that you will keep in mind looking at this video? Can you explain some of the challenges that this might have? Yes, anyone? Of course, jihad paths, identifying a path, of course, and that would be a direct application of state space representation. So you have to represent the the museum, the map, inside map of the museum as states, and then you'll have to connect them, identify the paths, right? Obstacles, identifying the obstacles, and then avoiding those obstacles. And what are those types of obstacles? Jihad, if you can explain this. So you said there are two types of obstacles. So what type of obstacles do you think there are?
I guess first people,
Yeah.
and the second might be the things, the I don't know, like
Okay. So maybe the frames or fixed obstacles that are which Jihada just pointed out in the chat. And then there are surprise obstacles. So surprised and fixed obstacles, technically, you can say that there are obstacles that are static, they are not moving. And then there are obstacles which you need to avoid, uh, which are dynamic, which are changing their position, right? So you saw this in this video that one of the children actually brought I mean came in front of this type of an agent, and then the agent actually changed its direction. Okay, so you're right. So you have fixed obstacles and you have got or static obstacles and dynamic obstacles, right? Path planning would be part of it, because you'll have to cover all the the objects that are present in the museum, all of them. Okay, so the agent also have to remember that the agent was at this particular place, or the agent has been at this particular place before or not, right? So in order to identify that, that has to be kept in memory, in stock, that okay, this path or this place has been visited before, so you don't really take the visitors to that same place again, right? Okay, but overall this is a complex environment. Okay, and this would require some next level of algorithms to actually solve these types of problems. Identifying the obstacles and avoiding them would require obviously some sort of a camera solution there, some sort of maybe other types of sensors also. You also need to identify the distance from the obstacle. Okay, so how far a particular object is. whether that object is stationary or moving, you'll have to identify the distance. Okay, so that type of a sensor has to be required. And then the agent function has to be complex. I mean, this agent function is really complex agent function. Right. This becomes more complex because you are interacting with people here. The robot is actually interacting, or the agent is actually interacting with real people in this particular scenario, and that makes it a bit more complex. Okay, anyway, so that's another example of having agents, and then obviously you'll have to have a map of this particular place. You have to identify the path, which is shown in the, yeah, so which is shown on the right hand side, which is in the grayscale. And then in the middle, you see a diagram which shows a laser scanner, which tries to identify that how far a particular obstacle is. Okay, so if you want, I mean, I've got this request that we can have a small break. So if you want a small break, we can have a break of 5 minutes maybe, and then we'll continue. Is that fine? So I'll try to explain the problem solving method or the approach in artificial intelligence, given any type of problem. Okay. Okay, so let me just write it here so that you can actually understand. The first thing that you need to look at is the sensing part. Now, when we say sensing, it means that you need to know that how would you perceive about the environment. Okay. And for example, all these three different applications that I've just shown you, the environment was quite different, and the method that was used to perceive the the environment and the situation was actually different. So the first thing is sensing, and there are issues associated with this sensing. And what are those types of issues? Okay, the first thing is that what type of sensors are required. Okay, so what type of sensors are required? That is the first thing that one needs to know. For every problem, you'll have to find out the type of sensors that are required. Okay, it may not be a complete hardware problem. You'll have to think of sensing in a different way also. Say if it is only a software solution, okay, if there is no hardware involved, even then sensing is required. So what type of sensing would be required in that case? I mean, the type of inputs that are going into your program, that could also be considered as sensing part, right? If there is hardware involved, for example, if you are building a robot, then of course you'll have to have sensors. You have to find out sensors which are identifying the distance of the robot from the obstacles, for example. You will require sensors to recognize something, right? For example, you will require camera sensors, things like that. Okay. So that's like what type of sensors are actually required. The second thing that you need to know is the challenges. That what type of challenges you will come across. And in case of Rhino, you saw that there were quite a few challenges that were actually required, that were required to be solved. Say, for example, how will you deal with people moving around? Okay, your sensor should be good enough to detect the movement. Then the challenges would also include what happens if the sensors are not working properly. Okay, so these are the types of challenges that you might have to face, and you'll have to come up with a solution to these challenges. The second most important thing is that once you have got the sensor information, the values that are coming from the sensors, the second most important thing is pre-processing of information. Pre-processing of information would mean that what would be the processes that you will actually be doing on the sensors. For example, if you are getting signals, if you're getting camera feed, pictures, if the resolution of those pictures is low, or if you are getting a video, if the video is, let's say, if there is a break in the video, you are not getting continuous video, right? Then you will require some pre-processing of that information. You will require, in other words, some sort of refinement of the information that you are getting from the sensors in order for the sensor information to make sense, right? And that comes under pre-processing, right? Say, for example, if you want to detect a color in a particular color, for example, if you want to identify the face of a person, the skin color is different from any other color. Okay. So you have a camera. The camera is giving you a picture or a video. And from that video, you have to identify a specific color. This is the color of the skin, for example. That would require some pre-processing, some processing of information, right? And that is the second thing that you'll have to think about. And this is when you are solving a problem using AI approaches. The third most important thing is the algorithmic part. Solution strategy. What should be the solution to the problem? You have to come up with the solution. Say, if you are recognizing objects, you have to come up with an algorithm. You have to come up with those steps that would recognize, or that would help you recognize a solution. And that solution will be applied on the pre-processed information that is coming to you. Okay, so once you have got the solution, the next important thing is action. So based on the solution, what is the sequence of actions that you need to determine or you need to apply? Say, if you recognize a person in a frame, you have recognized the face of a person, what should you do? That depends on application. Okay, you recognize the face and then allow that person to come into a room, or allow that person not to allow that person to come into the room. Okay, and that's the ultimate action that you'll have to actually determine. Okay, and the next most important thing is the environment. You need to determine what type of environment you are operating in, right? Okay, now this is very important. You need to know that what type of environment you are operating in. For example, in case of Rhino, the example of Rhino, you saw that, and we'll try to identify that what type of an environment it was. Okay, so now I'll give you the types of environments, and then you can determine based upon the problem that you are trying to solve, that what type of environment you are in. Okay, so let me just show you, tell you the first type of environment. The first type of environment is what we call as observable environment. And the opposite of that is non-observable. If the environment is observable or non-observable. Now, what would you mean by that? Okay. So now Can you give me, okay, observable, it's very clear from the name, something that you can observe, something that you cannot observe. That is primarily the difference between the two. Observable and non-observable environment, right? Okay. So let's say if you are moving on a road, okay, if the car is moving on the road straight, there is no turn. You can observe along the length of the road. Everything can be observed. But if there is a sharp turn and you can't see on the other side of that turn, of course, that becomes non-observable to you. Okay, so if you are in a room and there is a wall in between, the other side is non-observable. What is present in the room is observable. What is not present in the room is not observable. Okay, so does your environment contain everything that is observable, or your environment contains something which is not observable? Okay, so if you are solving a navigation problem, if you are moving between cities, of course, you have some observable scenarios and some non-observable scenarios, right? So non-observability, I've told you that if you are standing somewhere on a road and the road is straight ahead, there is no left turn or right turn, then of course it's 100% observable. But if there is a turn to the left side and you are far away from that turn, you can't see what is on the left hand side. So that is hidden from you. It becomes non-observable. So you have to determine whether your environment consists of observable states or non-observable states. That's one thing, right? Then the other important thing about the environment is whether it's static or dynamic. That means, are the objects present in the environment changing, or they are static? Now, on a road, if you are on a road, is that a static environment or a dynamic environment? I mean, it's very clear that it's a combination of two. If there are buildings on the sides of the road, of course they are not moving. The buildings are there, okay? Or if there is a signal on the road, or there is a billboard on the road, that is not changing its position. So it's static. But then there are cars moving or people moving on that road, on the footpath, on the sideways. That makes it dynamic. Okay. So environments are static or dynamic. And so far we have seen that all the examples which I've given you, Rhino, MIT Cheetah, LitNet, and before that, this vacuum cleaner thing, it was a combination of static and dynamic environment. The robot was able to move, therefore it was dynamic. Then you have got another aspect, which is called the accessibility. Whether the environment is accessible or not. Okay. So what would this mean? This would mean that whether you can reach from one place to another place easily or not. So if there are road connections, if you want to move from one place to another place, if the roads are clear, you can very easily move. But let's say if a road is blocked, okay, in that case, in the blocked path, you will not be able to go to that blocked path. So that blocked path becomes inaccessible. So whether your environment is accessible or inaccessible, that's another important thing. And finally, this is again very important, that whether your environment is deterministic or stochastic. Okay. Or you can also like call it probabilistic if you want, or stochastic. Now, what does that mean? Deterministic would primarily mean that that you are able to access, or you are able to determine what's coming ahead. Okay. So a very simple and a very concrete example of this could be that if you are on a road and the weather is clear, so you can see quite far. But what if there is a fog in the weather? If there is smoke there, you can't see beyond that. Okay, so your visibility is restricted in this case. You can somehow try to tell me that, okay, probably probably this is something which is coming, but you can't be 100% sure about that because there is fog or there is smoke there. Okay, so your vision or your view is blocked, right? Say if you are sitting in a room and you have a glass window, and if the glass window is not that clean, it's dirty, let's say, so you can't clearly see outside, but you can have some estimate, some idea that what is outside the room, because still you can see through something, but you are not 100% sure. So that means that you have some sort of doubt in your mind. Okay, and that's what probabilistic or stochastic would mean. Okay, so stochastic or probabilistic. And then you have deterministic, where you are absolutely sure. Okay, that's so if that window is clear, you can very clearly see that there is a tree outside. But if it is not clear, you can see that, okay, oh yeah, I think it's a tree, I'm not 100% sure. So if that's the case, then it's probabilistic or stochastic in nature, right? And then the other environment, and that would probably be the last or the second last, which is called discrete versus continuous. Okay, that's another type of environment that you can actually have. Discrete or continuous. Discrete would primarily mean that, okay, the information that is coming to you is not continuous. That means that if the information is coming to you after every half an hour, let's say, so obviously it's not continuous. But if you're seeing a video, if a camera is there and you are getting that feed from the camera, that is continuous. If you have got sensor in your room that gives you the temperature of the room, and if the temperature value comes to you after every 5 minutes, it becomes discrete. But if the rate at which it is coming is very high, for example, in your cameras or in your mobile phones, the video that you are capturing is 30 frames per second. So in a second, you are getting 30 frames, let's, of that video, right? So that becomes continuous. Though it's still discrete, but the rate at which you are getting that information is very fast. Therefore, we'll consider it to be continuous. So whether your environment is discrete or not, or whether your environment is continuous or not, you'll have to determine that. Why would you determine all these things of the environment? Because they directly affect your solution. If it is discrete, then you have a different solution. If it is continuous, then you have a different solution. If the problem is stochastic, you have a different approach to solve it. If the environment is static, the approach is different. Okay. And then you can basically also think of your environment in terms of another term, which is called episodic versus sequential. Okay. So now let's see. Can anyone tell me what would be the difference between episodic and sequential? I mean, just a wild guess, whatever you think. Just try to let me know that what do you think is the difference between episodic environment and sequential environment?
excuse me.
Go ahead.
I think a sequential environment means that in order to do an action or to take a decision, it depends on a pre-decision or action, one by one after one, I mean. No, episodic, um, I guess it will be the opposite.
Mhm.
Uh, it can the actions or the decisions can collapse, or at the same time, it may take more than a decision or an action.
Okay, Tania, thank you. Anyone else who would like to suggest something? Okay, so let me give you an example and then you can tell me whether this is episodic or sequential. So if you have, let's say, a table, and on that table you have placed some objects. Okay, and I develop a robot which picks objects of color red. So the task of that robot is to pick objects that are of color red. That's the task of that robot. Would you think, what do you think? This type of a problem, would that fall under episodic or sequential? Yes, Rania, you can start and maybe then the others could also join in. What do you think?
I don't know. I think it depends upon the algorithm that it's designed upon. If it's designed to pick the first trade one um, randomly or one by one sequentially. I guess sequentially.
Okay. So I've got a message from Ala. It's a long message, so I'll just try to see that. Okay, so I'll just read it. So you just said that episodic typically refers to something that occurs in episodes or individual segments, often with each episode having its own self-contained story or plot. Sequential, on the other hand, suggests a continuous ordered progression where events or elements follow in a logical sequence. So the difference might be in how the events are structured. Okay, so I mean, your answer is also quite comprehensive. But coming to my example, that if you want to pick objects of red color from a table and there is a robot which is doing that. So if I pick, let's say, object one of color red and place it somewhere else, and then I pick another object of color red and place it somewhere else. Now, are these two actions dependent upon each other in any way? I could have picked the second object first and placed it instead of picking the first object. Or if there are three objects, I could pick them in any sequence. I could pick object 3 first, then object 1, and then object 2. Unless I am restricted that, okay, you have to start from the left of the table and whatever comes first, that has to be picked first. If you don't pick it, then that's actually a wrong sequence. So in the second case, I'm given a sequence. I'm given the order in which an action has to take place. So my first action or my second action would depend upon my first action if it is sequential. And if it is non-sequential, I can actually perform the task in any order. Okay, so if the task is only to pick objects of color red, that becomes episodic. But if I am given a task that, okay, you have to pick the smallest first, and then you'll have to go to the next one, and then you have to go to the next one, and then you have to go to the next one, then that becomes sequential, right? So the difference between episodic and sequential in simple terms is that your second action is not dependent upon the first one. That is what episodic would mean. If the two are independent, then that's episodic. And if they are not independent, then that's sequential. Okay, now my last question. Coming to the rhinos example, what do you think the environment was? Episodic or sequential? Remember, the task was, in Rhino's case, the task was to actually take the visitors to all the exhibits that are present in the auditorium or in the museum. Okay. So is there a sequence there? Or is there a or is there no sequence there? Okay. Okay. So Jihad has just mentioned that it would be a sequential thing. That's perfectly fine. If you have gone to a history museum and you want to, let's say, have a round of that, you start from, let's say, 1800s, and then you go come to 2023, and that's how you can actually move in a sequential manner. If you start from 2023 and then you go to 1993 and then you come back to 1800, then the sequence actually becomes or is disturbed. So if the task is to go in a sequential manner, okay, from year one.
भावलपुर में सराइकी बोली जाती है या पंजाबी बोली सराइकी ज्यादा है ना?
Bakar, please mute. Okay, so that depends again the task that you are actually trying to perform. So it could become sequential, it could become episodic also. So if you are asked to cover, if you are asked to move from floor 1 to floor 2 and then to floor 3, and that is the sequence, then that becomes sequential. But at one floor, if you are not given a particular order in which the robot has to move on that particular floor, then it becomes episodic. So it becomes a combination of episodic and sequential. Okay. Okay. That's perfectly fine. So it could be a combination of episodic and sequential. Okay, in the slides, I've given a complete analysis of the rhinos example and with respect to all these different types of environments. So you should go through the slides and see that whether those slides are making sense or not. We have talked about static and dynamic environment, accessibility and inaccessibility. We have talked about in the slides deterministic and stochastic. Deterministic and stochastic, it's even Rhino is a deterministic as well as stochastic. If there are fixed objects present there, that's deterministic, but a person could come in front of that robot anytime, and and that would also make it a bit probabilistic and stochastic in nature, at the same time dynamic. So it is not like one of these, it could be everything together. It could be it could be observable with dynamic, with some inaccessibility part also, with some deterministic and stochastic part, with some discrete and continuous part, with some episodic and sequential part, right? So that's important. And just the last thing before we move on, whenever you are trying to solve your AI related problems, there are two things that you need to keep in mind. One is the AI problem that you are trying to solve could be goal oriented, and it has to be goal oriented. You have to have some goal in mind. And the second thing is that it should be utility based also. When we say goal oriented, now we give an example of that vacuum cleaner, that you start from a particular state and you have a goal state in mind. That's goal oriented. You have your start position, you want to go to a certain position, that is goal oriented. Now, what would utility based mean? That you should go to your goal position using the best possible option. And that analysis or identification of the best option is done through some utility function. Okay. So in case of the vacuum cleaner problem, I gave you a state space. It's a goal-oriented problem. Of course, it's a goal-oriented because you want, the goal is to complete both the room, clean both the rooms. But at the same time, it's also utility-oriented. Why? Because you want to achieve your goal in the best possible manner at the lowest cost, at performing very less number of steps. Okay, so this is what a goal orientation and utility based would mean. I hope this is clear. If there are any questions about this, let me know about this and about the goal and the utility orientation. So is this thing about goal and utility clear? Okay, Jihad. Thank you. Anyone else? Okay. We have Doha, Farah, Mask, Tania, Sanad, Ala, Ahmed. So are you guys also clear about this? Nice. So if there is any confusion, now you have like multiple options. You can contact me, or you can also contact Osama anytime during the week. And you can discuss your problems. We do have a WhatsApp group, so you can try to have some discussion on the WhatsApp group also. So I guess this ends our discussion today, and